After you came to Berkeley, it seems there's been a real blossoming in applied and computational mathematics here. And there's many people around, lots of graduate students, faculty in other departments that do that. Can you say why? Why do you think that happened here?
Well, to some extent, it's the progress of science. Right? Computation is becoming a bigger and bigger part of lots of sciences, and departments such as chemistry or engineering hire more and more computational people. That's part of science. The world is changing. In math, in the early years, the mathematics department was very supportive of the idea of computational mathematics, applied mathematics. Again, Chorin played a very big role here because he had lots of authority and he was supportive. He was making sure that the very good Chinese students went into applied mathematics. When some prospective appointment came up, which I thought was good, he looked into it and said, yes, this is a very good idea, and people would follow him. And again, Smail was very supportive, and Smail has been defining himself as numerical, and a very different style from mine, but still doing very computational and very interesting. And therefore, the growth was natural. Occasionally, there was some of you saying that this is not really the usual kind of mathematics, but not much. So the growth in the mathematics department was I would say organic, and simply there were people in the department who were forward-looking, and there was responding to what in fact were the needs of science. In recent years, there's been a bit more voices saying that this is too unlike the standard kind of mathematics. To some extent, maybe because, in fact, the computational mathematics is changing and may be changing partially away from math. It's, to some extent, it's a measure of its success. In fluid mechanics, when I was starting out, the big issues was how you conserve mass in calculation, which is a mathematics question. Now people try to deal with very complicated geometries and data sets and very technical issues in boundary structure, which are either computer science or engineering questions. So there's some kind of evolution there too. But I think on the whole, the mathematics department should get lots of credit for being very forward-looking and very broad in its definition of mathematics. And the lab, the growth also was to some extent, there was some computational mathematics here. More people came, a connection made with other departments. The Department of Energy moved some things here. It's an organic growth. So I think it's been very good.
Well, one thing I think I've noticed at Berkeley is that some of the students one gets that choose to do applied math don't come to Berkeley claiming they want to do applied math.
Yes.
So it seems that there's lots of changing colors.
Lots of changing colors. So indeed, well, partly the reason for that is the recent years, as the number of students is decreasing, it's harder and harder to make room for people who have a somewhat unorthodox background, which is what many of the future applied mathematicians have. So that's an unfortunate event. On the other hand, of course, inside the math department, we have been viewed as a successful group and doing good stuff. So it's easy to seduce people away from pure math.
Well, I think another thing you also put your finger on, which is that now that there are so many other disciplines in which to compute,
yes,
people say, I'll go to chemistry, I'll go to mechanics, I'll go to electrical engineering, et cetera. So yes, math as being the only home for somebody who wanted to do this has dissipated as well.
But there's a distinction between what we do in the math department, and what people do in other fields, because in other fields the emphasis must be on the specific application. You become an expert in doing calculations in a specific mode, in a specific case, in specific direction. In math, you can try to look at more general issues, at things which are common to many disciplines, and which have to do with differential equations, with the basic principles of what one can and cannot compute. So there is a role for computational people in math.